kind of show this last example we did using the quadratic formula instead of the square root, as some of you did ask for it. So let's see if we can do it. Picking up here with our ice table, and remember at this point we're going to put it into our k expression. So if we do that there, that would get us k is equal to our 2x squared divided by 0.5 minus x times 0.5 minus x, and that will equal our k value, which was 54.3 in this case. So we're going to basically take care of the top here. So that's going to be 4x squared. Remember that you do got to square the number there. It's very common that people miss doing the squaring part of that. They just square the actual x and not the number. On the bottom here, we need to do some distributing of those guys. So I'm just going to do it up here so we can just see the bottom part done. And once again here, we're going to go in and out on both of them, obviously. Kind of in and out. And when we do that, we will get here, we'll take 0.5 times 0.5, gets us 0.25. So what are we at here? There it is, 0.25. That's going to be minus 0.5x minus one more 0.5x, and that's going to be plus x squared. Combining our two x's going to obviously give us a 1. So basically this will clean up to 0.25 minus x, as this and this will equal 1, plus x squared. And that's going to be our bottom. So I'm just going to bring that back over here to our bottom. And that would get us basically 0.25 minus x plus x squared. And now finishing out there would be 54.3. Now we're going to take everything on the bottom here and multiply it to the other side. And doing that will leave us just 4x squared there on the left. Will now equal, we will get 54.3x squared minus 54.3x and plus the 0.25 times the 54.3. Looks like it should give us 13.575 in that case. Go. So just to verify here, 0.25 times 54.3. Yep. Okay, now we need to combine our x's. So again, I'm going to keep my x squared positive. So I'm going to basically subtract this to the other side. And when I do, I will now have my quadratic here equation, which will be 50.3 x squared minus 54.3x plus 13.575 in this case. That obviously here, we change color. I think I could do that. There we go. Maybe got it. That's going to be our A. That would be our B with the negative. And that would be our C as well. And by the way, that does obviously equal 0 here. There we go. All right, so into our quadratic here where we have x equals minus b plus or minus the square root, b squared minus 4ac divided by 2a. Putting in our number here, negative b will give us a positive 54.3 plus or minus. Now, if we do all the square root part inside of it first, that'll basically be 54.3 squared minus 4 times a in this case, which is 50.3, times c, which is 13.575. That is going to give us 217 0.2 inside the square root. Now if we take the square root of that, it's going to give us about 14.74 if you want to take it to a couple digits past maybe. So we'll go 14.74-ish. All right, that's all now going to be divided by 2 times a on the bottom. So that's going to be 2 times 50.3, and that's 100.6 when you do that. All right, that's going to give us our 2x answers here. We'll go with a different color here. We'll go with red. Why not? All right, so we'll do the positive way here first. So the positive way will give us an x value by taking 54.3 plus 14.74 basically divided by 100.6, going to give us an x value of 0.6863. Let me erase that. That's just a little extra guy there. The other way there, I'll do it in green, it's going to be the subtract way here. So we'll go that way. And that's going to be 54.3 minus 14.74 divided by 100.6. And that is going to give us an x value of 0.393, which I believe is what we got when we did it with the square root method. Now you're looking at this, and this is an example, as I was talking about in class, where you do get 2 positive values here. Right? So how do we know which one we should choose? It follows the same reasoning. We're going to take these x values here and choose one that works, and they're going to go back into our equilibrium line. So obviously, if we put that x value, the top one, into the 2x, we're good because it's a positive number. But where we do run into problems, though, is if we put it back into this spot here or here, because if we did, and that first one was the value that you wanted to use, that would be saying that the concentration of H2 at equilibrium would be 0.5 minus 0.6863. Get that 3 to right. There we go. And obviously, as you could probably see without the actual number, but we'll put it up there, and that is negative 0.1863, and you cannot have a negative concentration. So this is no good, which means this guy is too big. Also meaning not so good. That means that clearly in this case, just like we got by taking the square root, instead of doing the quadratic in this particular example, this guy here should be our correct x value. And obviously we would put that back in like we did when we were working out in class, and we would see that the concentration of H2 actually will also equal the concentration of I2, and they're both 0.5 minus x, so in this case we would use our correct value, and that would give us 0.107 molar for each of them. And same deal as we did before, and these would be these guys at equilibrium. For our HI at equilibrium, it would be 2 times x, 0.393, and that's going to give us the same value I believe we got in class there, which is 0.786. And again, it does need molar, as is the molarity. And once again, if you put those values back into your K value, and that would be our 0.786 for our HI, which we would square, and we would divide it by 0.107 for the H2 and 0.107 for our I2. We again should get pretty much the equilibrium constant value that we started with, and in this case we will end up with again, about 53.96, which is pretty close to 54, which is pretty close to 54.3 where we started. So again, that's a good way you could check yourself, just to make sure you didn't mess up anything if you did take the quadratic root. So I hope this helps. Some of you did want to see sort of the quadratic version of this. And again, you do see, you do get the same x value. In this case, again, you do get two positive x values, but the key is when you go to put it back into this equilibrium line, although it may work for one spot, it definitely does not work for the others. So it does have to work for all the spots on the equilibrium, and what I mean by that is when you put the x value in, it's got to hit a positive number for everybody at equilibrium. You can't have a negative concentration, nor can you have a negative pressure. All right, well, I hope that helps, and that will be it for this one. Have a good one.